There are few human experiences more universal than gazing up at the night sky, and the urge to look up is probably as old as our species, if not even older. But how did our ancient ancestors feel about what they saw in the heavens, and how did it influence the way they lived their lives? For Scientific American Science Quickly, I'm Rachel Feltman. You're listening to episode 2 of our 3-part Fascination miniseries on unusual archaeology. In this segment, Kata Karáth, a science journalist and documentary filmmaker based in Ecuador, introduces us to archaeoastronomy, the study of how people in the past experienced and explained the phenomena of the cosmos.
We have many different universes, dimensions. For example, Milihaimo, it's the realm of the gods. So the ancient Sami, they thought that it's kind of behind the stars, so that they are the holes to that dimension.
That's Ante Aikio, an indigenous Sami storyteller and reindeer herder who lives in Levi, which is in northern Finland, some 150 kilometers inside the Arctic Circle. A moment ago, you heard him yoiking. That's a traditional vocal technique among the Sami that's used to evoke, for example, a feeling, place, person, or animal. Ante said he created this melody during a long summer storm that started suddenly as he was herding reindeer.
There are two really important gods, which are Päivi, the sun, and Manu, the moon. And of course, it's logical because the sun has been giving light for us, and also the moon has been giving a lot of light for us.
The ancestral lands of the Sami, the European Union's only recognized indigenous people, include parts of 4 countries, from central Norway and central Sweden across Finnish Lapland to the Kola Peninsula in Russia. Some land here is covered in lush woods, other parts are home to green highlands, treeless plains, or Arctic tundra. For more than half the year, much of the landscape is covered in snow. The sky is vast, and the Sami people's gods seem to be locked in a fight between light and darkness. In summer, Päivi, the sun, dominates Manu, the moon, and daylight stretches beyond 24 hours. But in winter, the sun cedes its gains to the vast folds of night, which cast the land in moonlight, sometimes tinged with the ghostly specter of the northern lights.
My grandmother or my mother even, they said, don't whistle for the northern lights because they might attack on you. Then I heard that Eastern Sami had legends that they were kind of spirits or souls of murdered people.
Even today, the homeland of the Sami people is sparsely populated, but the area is subject to many industrial land use pressures. While the comforts of the modern world certainly aid the life of the Sami, their culture depends on the area's relatively unspoiled nature. That landscape may look like wilderness to some, but it's in sustainable use by the Sami. The traditional knowledge of the Sami stays alive in the land-based livelihoods still practiced today. Thus, concepts about celestial bodies in the sky, which have guided the lives of the Sami for centuries, have been preserved too. Long before humans had telescopes, people all over the world nonetheless endeavored to understand the cosmos. What did they think about when they looked up? To begin to answer these questions, I'm going to take you into the world of archaeoastronomy. It's a field that studies how ancient people thought about what they saw in the sky. It explores how they understood celestial phenomena and what that meant for their understanding of time and space. But to go on this time-traveling cosmic quest, I need a guide. And I have found the perfect one, Hungarian archaeoastronomer Emilia Pastor. Amelia has spent decades researching Bronze Age Europeans' connection to celestial phenomena some 5,300 to 3,200 years ago. I have been following her work for almost as long as she has been doing it. That's because she also happens to be my mom.
Well, when I was young, I wanted to be an astronaut, and I always dreamed about flying to discover the universe. I love science fiction, so it based my dreams. But then I realized that I am afraid of flying very much, so I had to find another profession, and that was the archaeology. Archaeoastronomy merges the two areas without the danger of flying.
Meanwhile, my interest in this topic came after copy editing dozens of her research papers throughout the years. So these days, thanks to technological marvels like the James Webb Space Telescope, we can peek into distant galaxies and witness the birth and death of stars. Ancient people didn't have any of that. Why would they have cared about space at all?
People of the modern age hardly notice what is happening in the sky and may only pay attention to striking phenomena, such as a solar eclipse or a big storm with lightning. However, the world of prehistoric man was not polluted by artificial light, and since they needed to know the weather, they must have carefully observed weather and celestial phenomena.
So what has archaeoastronomy work like hers shown us about their sky-gazing habits? Could they recognize more complex phenomena as well?
Prehistoric people definitely noticed the cyclical nature of the sun and the moon early on, and even the sun's two extreme positions, the winter and summer solstice, might have been highlighted in their lives. They must have also noticed that there are stars and groups of stars that never disappear, and some that return seasonally. However, Bronze Age solar symbols are very diverse, and I have discovered during my research that many of the shapes and forms actually match up with the basic structure of more unique atmospheric light phenomena like sun halos.
A sun halo is an optical phenomenon that shows up when tiny ice crystals in the atmosphere refract or bend sunlight. That creates a ring of light around the sun, and Amelia has found representations of related solar spectacles too.
I found examples of other phenomena, such as mock suns, as well as sun pillars, which are quite rare.
Mock suns can also form when ice crystals refract light, creating small luminous spots to the left, right, or both sides of the sun. And sun pillars look like columns of light shooting upwards from the sun. These show up when falling ice crystals reflect sunlight.
I even found ethnographic parallels on shaman drums thousands of years later, so this discovery has really opened new trends in archaeoastronomy.
And these early astronomical observations manifested themselves in many ways in Bronze Age people's lives, sometimes when you would least expect it.
One of my most exciting findings took place unexpectedly. I work for the Turista Museum in southern Hungary, and I was at the museum's conservation experts workshop looking at a pendant we had found in the tomb of a heavily jeweled woman during the excavation of a nearby Bronze Age cemetery. I was looking at it to determine whether the conservator had cleaned it well enough for us to start examining it. I turned toward the window to get a better look because the light was pretty dim. Then I realized that it was a shining Bronze Age solar symbol. The amber pendant glowed crimson in the sunlight, with a dark cross-shaped symbol in it.
We can also find celestial symbols decorating pottery, drums, and other objects. One of the most famous archaeoastronomical finds is the Nebra Sky Dis, dating back to roughly 3,600 years ago, though there is some debate about its age. It's a bronze disk with a diameter of about 32 centimeters that's adorned with golden celestial symbols and was found on the Mittelberg Hill in Germany in 1999. We can see what many researchers identify as the sun, the crescent moon, stars, including a grouping that could be interpreted as a Pleiades constellation, and even a symbol that might represent a boat or rainbow, depending on who you ask.
According to generally accepted opinions, it is the earliest, somewhat realistic, representation of the sky and some of its characteristic elements. Unfortunately, there is a grave issue connected to it that it was found by treasure hunters who are not trustworthy people. Therefore, the circumstances in which it was found, and which would normally help us a lot to study the object, such as the location where the disk was found and the other artifacts it was buried with, are ambiguous, and therefore the various interpretation of the Nebra disk can also be questioned.
This level of uncertainty regarding an object's origin in space and time is fairly common, so unlocking the mysteries surrounding an item's use requires a lot of creativity and collaborations with researchers from other fields of study. Regardless, objects like the disk are fascinating. And despite their uncertainties, they can suggest how prehistoric peoples, at least in Europe about 5,300 to 3,200 years ago, interacted with the heavenly bodies.
Earlier scientific work thought of the disk as an instrument for measuring the sun's positions at sunrise or sunset in order to obtain a calendar date, but these theories have since been dismissed. Nowadays, some German scholars claim that the Nebra disk is actually a mnemonic device which can help to calibrate solar and lunar calendars by syncing the relative positions of its golden celestial symbols, like the crescent moon and the supposed Pleiades constellation, with the real night sky.
So, what does Amelia think of these ideas?
I disagree with these theories because it would have required an understanding of mathematics at a higher level than we have clear evidence for in Bronze Age Europe. It's highly likely that the disk was a physical but also symbolic representation of the cosmos, and it played more of a spiritual than practical role.
Whatever the case was, it seems like something was going on with people and the sky then. Bronze Age dig sites in Europe and other parts of the world show a significant boom in archaeoastronomy related artifacts. A surge in celestial paraphernalia is consistent with researchers' understanding that more complex communities had begun to form, with a growing class of wealthy inhabitants who could afford luxury items such as gold jewelry. They may have used this jewelry, which shine with the same golden hue as the sun, and other objects endowed with celestial symbols to show their link to gods and demonstrate power and authority. By the Bronze Age, people's way of life had already begun to change. Humans increasingly moved away from living in small nomadic groups in favor of joining larger settled communities that relied on agriculture and animal husbandry. As these communities grew in size, simple astronomical observations also became crucial for survival. Noticing the regularly changing phases of the moon, seasonally appearing constellations, or shape and color of clouds on the horizon could give you an edge in navigating, predicting the weather, and even tracking time. Some groups took navigating by the sky to a whole new level. For example, Polynesian seafarers, following in the footsteps of their ancestors known as the Lapita peoples, used a method of ocean navigation called wayfinding, roughly 1,000 years ago. They perfected the art of traveling according to the stars, sun, wind, waves, and other natural signs instead of instruments, allowing those seafarers to undertake immense inter-island voyages. Amelia says it's important not to project our modern astronomical knowledge on earlier cultures. But even if we heed her warning, thinking about objects like the Nebra Sky Dis opens our mind to a fundamental question. It's one even prehistoric peoples settling into an agrarian life must have contemplated. What is time itself? That brings us back to Ante. Today, Sami people largely keep time like much of the rest of the world. But with the life cycle of the reindeer so central to the Sami way of life, their traditional understanding of time is cyclical and measured relative to environmental conditions rather than linear.
As a reindeer herder myself, we speak about 8 seasons in the year. So it's like spring, summer, summer, then summer, fall. then fall, winter, then winter, and again winter, spring.
Meanwhile, for the Aymara people of Bolivia, Chile, Peru, and Argentina, the past is known, so it's in front of them, while the future is mystery, so it's behind them. These variations in how we visualize and communicate about time to this day show it's more than possible that prehistoric people understood time very differently than we do now. But however one deals with the abstract idea of time, when it comes to keeping track of its passing, you need some kind of calendar. Most cultures, current or ancient, have relied on the cyclical nature of the sun or moon to create their calendars. Today, the majority of the world uses the Gregorian calendar based on observations of the sun, where a year is made up of 12 months, with each lasting between 28 and 31 days. And for most of the world, a day consists of 24 hours, an hour consists of 60 minutes, and so on. That amounts to a lot of math. Even if you try to look at it simply, thinking about a prehistoric person who realized there is a pattern to when the moon waxes and wanes or the sun rises and sets, they would still have to constantly monitor, count, and make note of these movements. About 29 consecutive days for the moon and roughly 365 consecutive days for the sun to get the bigger picture. So when we study the way prehistoric humans thought about astronomy, their earliest attempts at writing and counting become important pieces of the puzzle.
The earliest numbers that are unambiguous to our eyes are those from Mesopotamia. And we know in the middle of the 4th millennium BCE, so about 6,000 years ago. Why are they unambiguous? They're not just repeated, they're also bundled. So repetition and bundling are the way a modern number system works.
That's Karen Overman, a cognitive archaeologist at the University of Colorado, Colorado Springs. She studies how societies became numerate and literate, developments that did not happen overnight and most likely progressed at different paces in various parts of the world.
Numerical notations are like the last form of material representation. So we start with the fingers, then we go to things like tallies. Tallies can't be moved, so then we go to things like the tokens or an abacus. And after a while, you need something that will preserve longer than what an abacus can do or what a tally can do, and you develop written notations. So you don't start with written notations, and numbers often get treated as if they show up fully formed as numerical notations, and of course they don't.
And some markings that look like numbers to our modern eyes, in fact, had nothing to do with counting.
People tend to look at Paleolithic artifacts, they see linear striations, and they say, aha, numbers.
I asked Karen for a situation where this assumption was dead wrong.
What we have with the Australian message sticks is we have knowledgeable cultural informants that can tell us what those marks mean.
Australian message sticks, by the way, are wooden sticks inscribed or painted with notches and strokes that convey a message. Indigenous Australians widely used them for long-distance communication up until the 1970s.
There's one that says, we've laced the campsite with poison sticks and we've abandoned it and gone elsewhere.
Complex numbers and writing systems don't happen by accident, Karen says. History shows us that humans develop these systems only when there is a need for them, such as to keep records of large numbers or track longer periods of time. The earliest calendars were based on the movement of the moon, but as societies like the ones in Egypt and Mesopotamia became more complex and grew in numbers, Amelia says the lunar calendar became less and less reliable for tracking longer time periods, from a year to decades, with relative precision. It was also challenging to align the lunar calendar with the seasons. And so, for example, around the time that Egypt became a unified kingdom in the first half of the 3rd millennium BCE, it created a 365-day solar-based civil calendar that remained in use for centuries.
I think it's more tied to large bureaucracies and just the need to organize people if you've got to pay your workforce, pretty soon you're going to figure out you want to pay them only every so often because you're keeping track not to pay them more frequently, and they're wanting you to pay more frequently, but you only want to pay them when you need to pay them. So you have these motivations to say, let's keep things on track. And by then, what they've developed is a calendar that really is kind of ignoring the details of the lunar movement specifically.
Meanwhile, when researching places like prehistoric Europe, where written records largely started to emerge after the Bronze Age, archaeoastronomers such as Emilia have to get creative.
We will probably never have definitive answers about Bronze Age Europeans' knowledge of astronomy, especially without written records. But comparing Bronze Age symbols with astrophotography and looking at current indigenous groups such as the Sami and their relationship with the heavenly bodies can give us some clues about what prehistoric people could have thought when they looked up. I believe if we look at how prehistoric people understood the sky, we could perhaps understand just how deeply it has impacted humanity over countless millennia and take better care of the world surrounding us.
That's all for this installment of our series on niche archaeological research from around the globe. Tune in next Friday for our grand finale, where we'll explore one of the most extreme research environments on the planet. Science Quickly is produced by Jeff DelViscio, Fonda Mwangi, Kelso Harper, Madison Goldberg, and me, Rachel Feltman. Our theme music was composed by Dominic Smith. Shayna Posses and Aaron Shattuck fact-checked this series. This episode was reported and hosted by Kata Karáth. Special thanks to Saara, Alakorva, and Camilla Brattland for their assistance with parts of the script. For Scientific American Science Quickly, I'm Rachel Feltman. Thanks for listening.